couple caveats to start this off. For those of you who don't know me, which is everyone who doesn't work at KSMC, my name is Justin Bolles. I'm Senior Software Architect at KSMC. I've spent my career working in just about every language under the sun, with the noted exception of Python. So, I am obviously an expert in this territory. There are a lot of really smart people at KSMC who know a lot about Python and big data. You should talk to them. They're at the table over here. So what I wanted to focus today on is more some shifts that I see coming in the industry that affect all of us, whether or not you're working in Python or .NET or Ruby or I think there's some COBOL programmers out there still, probably. So that's what I wanted to look at today. So I apologize if you're looking for a really in-depth technical talk on Python. This isn't it. You can take a half-hour nap, and then some really smart people will come up after me. I will also caveat this by saying that I have spent the last 3 weeks with two and a half-year-olds that we just adopted, and I wrote this speech while I was in Africa. So with that as our background, let's get started. So I wanted to talk a little bit about the focus of the software industry as a whole for most of my career has really been around this idea of we're going to write code in one language, and then we can deploy that code before the internet across all these different platforms. And then with the advent of the internet, obviously, we have these teams that we have this one code to beat all, right? So back in the day, it was Java, right? And since we're all Java programmers, this obviously works really well. But there's the idea that you could write it once, and you could run it anywhere, and it was going to be great. And the problem that we ran into with that is, if anybody remembers, what did they call it in .NET? DLL hell, right? Where you had to have the right version of the right DLLs installed at all times. Java ran into the same thing. You had to have the right client. Sometimes those clients collided with one another. And what it turned into was you would just write it once and then you would debug it everywhere, right? And so when we got to the mobile wars of iOS versus Android, we then repeated the sins of the past, right? Nobody wanted to write their app for iOS and then turn around and write it again for Android. So we created these things like Appcelerator, React Native, etc. And the great idea was that we would write this one code base and we deploy it across all the platforms and it would be great, right? And what we found was that that also didn't work, right? So there's a great article. I think they're going to post this slide deck, right? So don't worry about writing down the URL. But there's a great article here on Medium and about Airbnb abandoning React Native. And what Airbnb found was that they would write their React Native app, and then they would have to maintain a separate code branch to do all the iOS tweaks, and then a third code branch to do all the Android tweaks. And now they're maintaining 3 code bases instead of 1, right? Which isn't optimal. So what we thought was going to be this great step forward of we only have to do we only have to write this once. Now we got to write it 3 times, right, instead of twice. So they went back to native and failed on that pursuit as well. And I feel like we're doing the same thing again with JavaScript, right? So JavaScript is a front-end language. And if you would like to argue me on that, don't. It's a front-end language. It is not a back-end language. I'm sorry, no developers, it's not. If anybody has ever tried to do anything with promises, they know what I'm talking about, okay? So JavaScript is not a front-end language. And what we have found through all of these trials and tribulations, through 20 years of trying to make one language do everything, is that one language can't do everything. It couldn't do it in 1998, it can't do it today, right? So how do we solve this problem? Or why did we run into this problem? Deployments and maintenance were expensive. I'm sure people here know or have stories of, it took a week to deploy new code to production, right? It takes, to get through QA, to get through UAT, to get through, the actual deployment process. We've got outage windows of hours, and that costs lots of money to organizations, right? So what we have run into as an organization, or as a industry, I think is a big change that has come. And it's come in the form of everybody's favorite buzzword, which is containers, right? How many of your bosses have been like, well, we'll just use Kubernetes, and everything will be fine, right? But I think this is exciting. I think containers are exciting for a lot of different reasons. And it's more than just some things that the sales guys can say during their sales pitches. The thing that excites me most about containers is that for the first time in a long time, we can actually allow each language to do its own job that it does really well, right? So Python or JavaScript can do the front end stuff, right? Ruby on Rails, .NET, these middle tier API languages can do their stuff really, really well. Python can do all of its great data analysis and data manipulation stuff, right? And we can put all of this stuff out there as one complete system that instead of at the beginning of the project saying, we're going to build this system in Python, right? So now we have to figure out how to get Django to work on the front end, and we have to figure out how to get all of these pieces to work together. And maybe this isn't optimal for this, but it's better for that, so we're just going to do that for the entire project, right? We don't have to give those concessions anymore. We can now use containerization to make it easier to go through that deployment process, right? And we can use containerization to allow all of these languages to do what they do really, really well. So I want to give you an example of that we've been working on recently. So here's our infrastructure. So we are collecting data from 16 different data sources. Some of that data is structured, some of that data is unstructured. Stephen will tell you most of that data is unstructured, and he hasn't slept a lot in the last couple of months, but he looks great regardless of that. So it comes in, and our really smart Python guys do a lot of really smart stuff, and they break this stuff apart, and they figure out what it means, and they dump it into a data store, and then our front end can come in and pick up that data and show it to the end user, right? And then we're going to use an Amazon queue, simple queue service, to be able to allow our front end to talk to the back end that's doing all that processing, right? Pretty simple. For those of you who have ever written software, you always start with a diagram like this, and it always turns into a diagram that looks like this, right? So it's never that simple. So we had to add a couple more services, we had to add a couple more things, we had to add a couple more processing points. But the beauty of this is that despite the fact that we almost doubled the number of boxes on the screen from slide 1 to slide 2, our deployment and our CI/CD was not any more complicated. All of these things are still running in containers. We just deployed a few more containers. It's all on AWS. And so it did not exponentially increase the amount of work for our operations, for our dev operations team, even though we made it exponentially more complicated as far as an infrastructure goes. So containers really allow each language to do what it does best, and then we don't have to go through and sort of bastardize some of these languages to get some productivity out of them at the end of the day. And please feel free to stop, ask questions, whatever. This is not going to take a half hour, so I'm banking on some audience participation. The second thing I want to talk about, and I know there's a talk later on Apache Airflow, which is going to be awesome. You guys want to make sure you pay attention to that. Apache Airflow is something that is a new concept for me, and something that I'm really excited about. So. But let's talk about reusable code. Reusable code is the holy grail of software development, right? Everybody wants to have this perfect, dry, object-oriented library of code that you just go pick your module off the shelf, you make a few adjustments to it, right? You plug it in, and off you go, right? And so your project just essentially consists of grabbing 3 or 4 things, putting them together, and you're done, right? I've never actually seen a software project go that way, right? You always pull something off the shelf and you're like, well, it doesn't quite do exactly what I want it to do. And then inevitably, when we get down to the very crunch time, there just ends up being a lot of copy and pasting, and we don't stick to our dry principles quite as well as we intended to whenever we started the project out, right? And so you come to a piece of code after 6 months, and you go, what was I thinking when I wrote this, right? So I think what's exciting about a product like Apache Airflow, and there are some other ones as well, is it really allows us to activate this idea of pipe and filter methodology around writing these small snippets of code that do something very specific, and then using that tool to string those snippets of code together, those jobs together, and then schedule them so they can run on a fairly consistent basis, or whatever basis you need them to run on. And so I think this is the first time where I've seen in action a situation where you actually do have a snippet of code that you can pull off the shelf, you can plug some things together, and reuse that code not only within the same project, but even across projects. So here's a quick snapshot of an Apache Airflow implementation. Like I said, there is a talk on that later today, maybe next. I'm not sure exactly what the schedule is, but there's a talk on that later today. I saw it on the schedule, so stay tuned for that, because I think you guys will get a lot more out of that. Continuous deployment. Everyone's favorite buzzword right now is DevOps. How many people read the reviews of the iPhone 11 Pro when it came out? How many people saw the reviews that said, this is the worst product that Apple's ever made, Apple can't innovate anymore, they're terrible? The reason that you were seeing this, in my opinion, is that everyone is getting used to continuous deployment. Every time you log in to some application, some SaaS application that you're using, you see some new feature set, right? We've got apps on our phone that update in the background now. So you just open them, and there's some new feature set sitting there for you, right? How many times do you walk in and or open an app and you have to hit the skip button to get past the tutorial, right? So we're used to this rapid pace of innovation and this rapid pace of new features. And when you only release a product once a year, you can't do that, right? So then everyone gets upset that they didn't get this new, cool, shiny thing that got rumored, because the rumor mill gets out of control, right? So the whole point of that story is that we, as a software industry, have to focus on how do we get new features out as fast as we can, and how do we get them so that we can reduce the cost of implementing new features, and how do we push code out faster, right? How do we make our users happier because we're introducing these new features that make our applications easier to use? And so we have been looking at a couple of things around using infrastructure as code, we being KSMC, and by we meaning not me at all, but that's okay. Using infrastructure as code to be able to spin up environments and spin down environments using software, right? And the idea behind this is that we can take all of this data that's being created by all of these folks that are doing just their jobs, right? Everybody's daily job creates some data point, right? And so we can look at all of these data points, we can package them up, we can then deploy them in a secure environment using infrastructure as code that allows individuals to be able to pull some insights out of those data sets, right? So to give you an example of what I'm talking about, we had a client that came to us and said, we have all this really secure data. We cannot allow this really secure data out of our secure area, right? And we said, okay. And they said, but we want to make it available to people through an approval process, so that they can go in and they can look at this data and they can pull insights out of this data. We said, okay, great. So we set up a workflow system that if they're approved, the data set is sitting out in Azure, right? And it connects to Jupyter Hub, and we spin up a Jupyter Notebook instance, and we give them access to the Jupyter Notebook instance, and they can do all their stuff in Jupyter Notebook, and everyone's really excited about it, right? So cool thing, we spin up all this stuff using infrastructure as code. spin it back down when we're done. Everybody's excited about it, right? Except for, here's a little diagram. Except for anyone who's ever worked with a client knows that as soon as you do that, they say, cool, but we can't actually use that, right? So they came back to us and said, everybody actually wants to use Tableau and Excel. No one really wants to use Jupyter Notebook. So this is all sort of worthless, so thanks for trying, but it doesn't work. So we went back and said, okay, we can figure that out. And so all we really had to do was tweak our solution a little bit and throw a virtual machine in the middle. So now they connect to a virtual machine. The virtual machine connects to the Jupyter Notebook. The virtual machine has Tableau on it, and they can do all their stuff with it, right? So we can do all of this stuff by deploying through software interfaces and through infrastructure as code, and we can create these really complex dynamic environments that are really, really interesting. So I will stop rambling here. So just to finish up here, containers reduce cost of deployment, and we can do some really cool stuff with them. Apache Airflow gives us the opportunity to string these different little snippets of code together and really build a code library that we can actually have reusable code. And then infrastructure as code really gives us a lot of opportunity around using these huge data sets that we're creating every day and putting them onto, and pulling those insights out of them in a way that's meaningful and useful for businesses. And that is all that I have. So thoughts, questions?
Yeah, if folks have questions for Justin, we can pass the mic around and get some feedback or quick things. Here we go.
Thanks. Yeah, so when you were talking about your CI/CD process not
Yeah.
changing with containers, can you kind of describe how that worked? Is it the content of the containers that changed, and then you just deploy containers the same way, or can you unpack that a little bit?
I'm sorry,
When you were talking about your DevOps and CI/CD process didn't have to change when you were using different languages deploying containers.
Yeah. So we use a product called Circle CI for our continuous integration and deployment. We also use a product called Sonar Cloud for static code analysis. So when we commit code, it goes through Circle CI, goes through Sonar Cloud, make sure that all that linting is good. And then we use Elastic Container Registry, I believe, on AWS. And so when we added more components, it was simply a situation where we created a new repository, we hooked it up to Circle CI, copied those same scripts that we had in the previous repository over to the new one, and so that build process was pretty much flushed out. And then through all of the tools, all the AWS tools, we were able to push those new containers out and get everything communicating the way we wanted it to. Does that answer your question? I don't know if I really did a good job on that, but okay. So the point there is a lot of it was pre-scripted, and we were able to copy the scripts and just make a few adjustments to them.
Just, can you go back to your slides, that blob and Tableau part real quick? So yeah, what is the need of Jupyter Hub if you have the VM, Tableau in the VM here? I mean.
So the need for Jupyter, so we have the VM that sits in the middle. The need for Jupyter Hub is to spin up a Jupyter Notebook so that people could do their analysis within that.
So they are doing it in the Tableau itself, right? In the so no, the VM is Tableau is in the VM. So
Tableau was on the VM. So
right.
the idea there was it gave people options, so that they could do Tableau, they could do Excel, they could do Power BI, or they could do they could use Jupyter Notebook.
Okay.
So they had all those options there, and then any output that was made from any of that stuff was then still secured, so that the user couldn't download that and take it out of that secured environment.